So an interface is also one type of Java class, and I can say that is a fully abstract class, right? Fully abstract class or fully unimplemented structure, we say that as what? An interface. And the most important structure out of all. So we have seen three different types of classes now. A class fully implemented, fully implementation is called as a class. Then you have partial implementation, we call it as a abstract class. Then we have a fully unimplemented structure that we call as an interface, right? So the name itself says it acts like an interface between mediator between two different right group of classes, right? So what is this interface and how we write it, right? So we use a keyword called as an interface, right? So interface name, interface name, and which contains all abstract methods by defaultly, which contains all abstract methods by default, that is called as an interface, right? So if you want to write here, so there is no doubt about there is no question about implementations in the interface, all abstract methods, right? So whenever you want to define some kind of specification rules, what everybody should do, but how they do, if you don't want to specify how they do, right? We define by using interfaces. Let's suppose yesterday we have taken some kind of interface called as, right, flyable, right? Right, okay. So this is also one type of inheritance, right? And this inheritance is called as interface inheritance, right? So inheritance between the classes is different, and inheritance between the interface is slightly different. What is the difference? You have inheritance between the classes, whatever you define in the superclass, a child class gets it as it is, right? So whatever you have in the superclass, a child class gets it as it is, but whatever you have in your superclass, the child class should implement it, right? So there I have taken a movable. So what is this movable here? A movable, I am defining some functionalities. What is the meaning? What is the meaning of a object which is movable? Right? Just I defined one method called as move, and any object in the universe which exhibits this move behavior, that is called as what? Movable object. Person here is a movable, I can make it, right? Person is a movable, as well I can make a car as movable, as well I can write a bird as movable. See here, different group of objects here I have, but still they can have some common set of implementations. And if you see from top to bottom, right, so there is no, it is not possible to implement this method inside movable, right? And anything which can be said as movable should have implementation of this move method. So technically this is very important point here. Technical point is, so what is this interface is going to do for you? Provides you one interface, right? Interface will provide you one interface and multiple different implementations. What is the meaning of this? So what is the meaning of one interface, multiple different implementations? Here is, now the move method will have one definition, but this move method will be implemented in multiple different ways in multiple different classes. This move method will be implemented in multiple different ways in multiple different classes. One interface, multiple implementations. That is the concept of what? Interface. One definition with multiple different implementations, and you don't know and how this implementation will be, in what class, how this will be implemented, in how it is implemented. We don't bother about it. We simply bother about it. Each and every movable object in the universe will definitely have a move behavior, and how it is implemented we don't bother. You understand what I'm trying to say here? So is this movable is a abstract class or it is a interface? Which one is correct? You can make this movable as abstract class also. Absolutely can make this as abstract class also with one abstract method. But which one is correct? Making it as abstract class or making it as a interface? Which one is correct? In theoretically, right? So making it as interface is correct. So different objects. It is not a common method among the group of objects. It is a common method among different objects, and it is defines a specification rule. Says what? Every movable object in the universe should have a move method, and whatever the object which wants to, which becomes a movable, definitely there should have a move method, right? It has a different meaning actually whenever we start discussing advanced Java. There we can see, or you can understand in a simple manner here, right? So here, let me take one simple example again to make you comfortable, right? Now, let's suppose here I'm taking very simple example again. Everybody might have come across this scenario, right? Definitely, there is no question about this example. Whatever I'm trying to give here, try to focus on this. So I'm trying to design, right? Simple. Again, one more example where to make you comfortable with this concept. Very simple, whatever you come across in your real time. Now here, see this. What is this? Question paper. Question paper. Right? So what a question paper will contain here? What a question paper will contain? Yep. Questions, fine. Only questions? Come on, speak out fast. Time, fine. Time, right? How much time will be given and questions. Next. Speak out. Only those. Marks assigned to each question. Good. Right? So technically speaking here, a question paper is set of some, in simple I can say, set of some guidelines. Right? Everywhere you will have some questions, how much time will be given, how many marks will be given, right? And what, so here, this is fine. Now what is the use of this question paper? What this question paper to be? And what it should be, how it will be used. Come on. What is the importance of question paper? I don't understand. No answers. Right? So question paper will be implemented. Right? What is it? Question paper will be implemented by different students. Right? So what are these? Different student objects. Imagine. Different student objects implement this question paper. And what they, how they implement? Right? Different student object will be there and they implement this question paper. Just example, student objects. They implement, each and every student will implement this question paper. What is the meaning of implementing a question paper? What is the meaning of implementing a question paper? Solving. right? So what they come up with? So there are group of students, there may be some group of students, right? Each and every student will be given the same question paper, yes or no? Each and every student will be given same question paper. Now what student has to do here? What student has to do? Each and every student will be given the same question paper, and every student will be implementing this question paper in the form of what? Answer sheets. What they do? Each and every student will implement the same question paper, yes or no? Each and every student will be using this question paper, right? And everybody is going to implement the answer sheets. The implementation. So what is the implementation of a question paper? The implementation of a question paper is an answer sheet by some student. Now my question is, yeah, now here all these answer sheets, whatever we are talking about, all these answer sheets which are implemented by the students will contain the same implementations, means same answers. No? Yes or no? No, right? So a single question paper given to multiple students, and multiple students will be implementing the same question paper in multiple different ways, right? So this is one. So you have one group of people here. What? Who are these? One group of people we have here. They are what? Students. And one question contains what? This question paper will not contain anything. Simple set of questions, and as we have said, some rules, what every student should do, how many questions he should answer, what is the time period, solve all these answers and questions and all. Every student will be solving this question paper, and they will write their own way of this implementation for the same question. Everybody writes his own way of the same, his own way of implements. Every student implements this question paper in his own way, right or not? Still fine. Still we can we connect any other group of people to this architecture? Still can we connect any group of people to this architecture? Teachers, fine. What they do? What they do, teachers? What they do, teachers here? Okay, fine. So it's a different. Okay, that's correct. Sets, right? So group of people will be there. If I take a board exam kind of thing, example, right? So there is a one more group of people who is going to define this one, giving the set of rules. All these questions are defined by one more set of people. And very interestingly, this group of people nowhere interacted, nowhere has a relation between what? The underlying bottom group of people. These are different people, these are different people. But they can interact with each other by one common interface. What is that? A question paper. Fine. So these group of people are what? Like who sets the question papers for the board exams. Example I am taking. Fine. So this is one group of people. They are giving you a question paper, and one more group of people, they are implementing this question paper. And interestingly, multiple implementations here. Still any other people you can connect to this architecture? Still any other people I can connect to this architecture? If you imagine this is a board exam where the question paper is set. Right? So there is one more group of people who is going to evaluate the answer sheets. So these, if it is your school, it is fine. The same person who is going to set and who is going to evaluate it. But when you come to board exams, you will not see the same group of people. Some different group of people will be there who are going to evaluate these answer sheets. And very interestingly, whatever the group of people I am taking here, no group of people are directly related to other group of people, right? No single group of people are directly related to other group of people, but how they are connected to each other? Did you get my question? There are three different group of people I have taken. One group of people who sets the question paper, one group of people who implements the question paper, and one group of people who checks, who uses these answer sheets. And very interestingly, no group of people are interacted with each other. Then how it is working? How they are able to communicate with each other? Through one simple interface called as what? No people, no group of people are interacting with each other. Now how? Now if I take this group of people who are there, who are going to correct your answers, what this group of people are going to do, how they are going to correct the answers, how they are going to give the marks, this people, how they will correct the answers and how they will give the marks here. Right? So here, how they, each and every evaluator is going to correct the question paper answer sheets and how they are giving the marks, right? For all these answers, only one, all these questions, only one answer, that is what? Through question paper. Where, if you see what this question paper is contained, can anybody say what this question paper is contained here now? What this question paper contained? Right? Every different group of people or different group of things, objects are connected to each other but without knowing each other. How it is possible? Now in this example, all different people are connected to each other, but no people knows what each group of people are different group of people, right? All are connected to each other through a simple interface called as what? There is one interface in between among all these objects. There is what? A question paper is acting like interface between all these people. And what is this interface is technically contains? What this question paper is containing? What this question paper contains? That's what is that question paper contains. Now you have student, some other group of people, you have a paper who is like teachers who are setting the papers, and you have evaluators who are evaluating your papers. All these people are connected to they are not directly related to each other, but still they can work as it they are connected to each other through a question paper. And if you observe, this question paper will not contain anything, simply set of rules, specification rules says what this group of, what these people should do, what this group of people should do, this group of people, right? So what this group of people should do, it contains that set of rules. What these people should do, this contains some specification rules given to what this, and what these people should do, there is some specification rules are given for these people. In the same way, something here. So different people, right? So again, how they should evaluate, how many marks they should give, for which question how many marks they should give, for which question, which answer, right? All these things are there. So it is some set of rules are defined, and everybody follows this set of rules. So this group of people, if I see this group of people are implementing this question paper, implementing this group of people are implementing this, but they are not implementing, this group of people are not implementing. What they are doing here, they are simply correcting the answers. How they are correcting the answers, how many marks they are giving based on the same question paper. See, different group of people are able to interact with each other through an interface. Technically that interface is not having anything, simple set of rules. What these people has to do, this group of people has to do, and what this group of people has to do, like this. And that depends on where you sit in this architecture. If you are in this architecture, if you are there here in this location as a programmer, right, in this architecture as a programmer, if your role is this one, this layer, so what you need to do here, you need to implement the question papers. And in this architecture, if you are here in this area, if you are here in this area, what is your responsibility? You are not going to implement it. Simply you will be using these implementations. Simply you will be using these implementations which are implemented for you. Okay, is it fine? What I am trying to explain? Are you able to understand this example, what I am trying to explain? Different people, different group of people are connected to each other via a question paper. And technically this question paper does not contain anything. This question paper contains what? Some specification, rules or guidelines, what each group of people should do and how they can interact with each other. That's it. Now what is this question paper becomes now technically? Is it a class? Is it a class? Yeah, now tell me, is it a class, this question paper? It never becomes a class because there is no implementations. It will contain a question. Write the answer for this, write the answer for this, write the answer for this. Who has designed this question paper, they also doesn't know how the answers will be written by different students. The same question will be implemented in multiple ways by different students here. Getting me? Right or wrong? Right? So the same question paper will be implemented by different students in different ways. That is the meaning of one interface. What is the one interface? This question paper acts like a one interface, and these students having multiple implementations for the same question paper. One interface, multiple implementations. That is the meaning of an interface. Most important class structure in the Java program, which does not contain any implementation, simply contains some rules, specification rules. Right? And it clearly defines which group of people should do what. Now, as a programmer, if you are here, you need to implement this. If you are here, you need to use it. Now let us take one more example, again one more real-time example to still more clearly understand almost similar example here, right? So here we try to understand by taking one more example. Yesterday whatever I have taken, the same example I would like to take here. But guys, don't buttify the things. Nothing happens if you buttify the things. Try to understand the concepts. Now yesterday I have defined one electronic device. Yesterday we have taken one electronic device called as a remote controller, right? What a remote controller, right, is, again same, again it may not be the exact example, but try to understand. Same thing I'm going to relate here. So a remote controller, as I had defined two functionalities yesterday, one is on and the other one is what? Off. Now you have different company people, right? I'm going to add different, I'm going to take different company people. You have the company people who implements TV, who builds TV, who creates the TVs, who creates music systems, who creates what? Still with DVD players. Lot of companies makes the remote controls, right? So these people are what? The implementers. What they do here? What they do here? So they know what they are going to do. They are simply making what? A remote controller for. They are making a remote controller. Each company people will design one remote controller. Now what this remote controller will have? How they design this remote controller? Right? How they design this remote controller? There is some, already there are some rules are given. If anything follows, any device, any electronic device which is created by following that rules, that is called as a what? Remote control. That means what? Some other group of people may be there at the top who might have designed these rules. But any electronic device which contains these properties, that is called as what? A remote control scientist. Example. Somebody, some scientist might be there who might have given what is the meaning of a remote controller. This is the definition you have for a remote controller, right? And this is implemented by different people. Different people will be there at the bottom, and they will be using there are some standard. What is the meaning of remote control? A definition is there. According to the definition, they are going to implement their products, right? So these are the products. So one more group of people are there. Who are they? Who are they? One more group of people I can add to this. Who are they? So this is what this layer. What about I am taking? These are the, this is the layer who are implementing, who are implementers, right? And this is the layer who designed, who has given what is an remote control. There is one more group of people here. What? Who are they? So these are the people, I can say this group of people who uses the remote controller. Nothing but we, normal people, who uses this remote controller. See here, different group of people are able. So here what you are doing here, the product which is developed by different companies. That is the first question I asked yesterday, right? What is my question? Is it possible for you to use a remote controller which you have not experienced before, which you have not used it before? You said, yes, I can use it. How it is possible? Because there is some standard set of rules are defined for it, and every remote control will have that standard set of rules implemented. The standard set of rules are implemented in each and every remote control. As a user, if you see, there are some group of people. As a user, there are some group of people. There is some group of team who are implementing these things. And a user, you are nowhere related to this group of people, right? So these are the people who are implementing these devices, who are creating these devices. These are the people who has defined what is a remote controller, and here the group of people who are using this. And nowhere each object, nowhere this group of people are connected to each other, but still they can interact with each other. How they can interact with each other? Right, by using a simple interface. By using a simple interface called as what? A remote controller. All are connected to each other through this interface. But you need to understand the rules of different people. If you are here in this layer as a person object, if you are here in this layer, what you are going to do here? You are going to implement it. So one definition, what is the meaning of one definition here? It is defines what is a remote controller mean, on off, that's it. But is the implementation will be same for this on and off in each and every remote control? Is the implementation for this on and off will be same in each and every remote control? Yes? Implementation of on and off behavior is same in each and every remote control. So how on and off will be implemented in a TV will be same as DVDs on and off? Yes or no? Are the same functional? I am not talking about the on and off. I am talking about internal implementation. Implementation of on and off inside a TV remote, inside a DVD remote, inside a what projector remote. In all cases, this implementation will be same. If all remotes have the same implementation, that means what? I can use that remote with any electronic device. The same remote can be used with any electronic device. Is it meaning? No. Each and every remote control will have what? On and off. But how they are implementing internally this on and off behavior will be definitely different from each and every one. No, on and off will be there. I am not talking about the functionality. Every remote will have on and off. But the implementation point of view I am talking. Each and every remote controller's on and off will be implemented in a different way. Right or wrong? Yes or no? So that is the meaning of, that is what this interface can do for you. Right? So that is what this interface can do for you. Right? So different group of objects can interact with each other in the programming, in the development environments, right? By using some set of guidelines. And technically this remote controller, this interface is not containing anything. It gives what is remote controller mean without any implementation. Right? As a user, so if you are there in this architecture, now you will be building, you will be creating a remote control by using these rules. If you are here in this architecture, what you are doing here? If you are if you are here in this architecture, so what you are doing here? Your roles and responsibilities are different, right? So you will be using this product. You are not going to implement it. You will be using this product. And also you know what, every remote controller will have what, on and off, right? So these are different group of people can interact with each other by using such kind of interface, right? So whenever you develop your applications, you also come across such kind of requirements, specification rules. So whenever you take a application, whenever you want to solve a application, first of all, what a client wants, all these things will be put into one rules. Now this project demands all these things. This project demands all these things. So that means these are the functionalities should be there in this project. So all these things will be put into what? Interface. That means what? Everybody should this must be these are the functionalities of this project, and they can be implemented in multiple different ways by different programmers, right? So these are the most important structures, right? So as we have defined, now how to write these things in technically by using a program, right? So to write these things technically by using a program, we use a special keyword called as what? We use a special keyword called as an interface. Again one more class, right? So again one more class here, question paper, or yesterday I have taken the same thing here, movable. What is the meaning of movable? Any object which has a behavior called as movable. I am defining the rules. Now in the universe, any object which has this behavior, that is said as what? Movable. It is not this behavior is not I am giving for a particular group of objects. It is universal. This can be given to any object in the universe, right? So this is what a movable interface, and which defines what? Set of rules. Again it is a class. Internally it is a class only. Internally it is a class only. It's already defined yesterday, right? So I'm using the same here. So it is a class again. Yesterday I think I had shown you, right? What is the meaning of this? Interface. Now what a class should do here, and how many you write inside this? They are by default public abstract. Most important interview question. There is no possibility of thinking what? Implementations at all inside this interface. Everything is by default public abstract. There is no question about implementations here. There is no question about implementations. Everything is by default public abstract, because it defines what everybody should do, but it does not know how it is going to be implemented. It says what everybody should do, but it will not say how it will be implemented. How a person is going to move, it does not know. How a body is going to move, it does not know. But it says what? Every movable object in the universe must have a behavior called as what? Move. That is what it is going to guarantee. Do you understand? Right? So I think yesterday I have taken the same kind of classes here. Where is that? Bike. Okay, fine. Right? Bike. What a bike can do here? Now bike is not extending. See, try to understand the difference here. Right? So this is an interface. This is a class. So what a class should do here? Class is not extending. Extending means what? Getting the properties which are already there. Getting the behaviors which are already there. But there is nothing inside the interface. So whoever wants to, the object which has this move behavior, right? It is going to define what? I am a movable. I am a movable object. And when it says I am a movable object, so it must have a what? Move behavior. So it should override the move behavior. So that means what? The object must implement it. It is not going to take anything. Runnable. Again, yesterday I have taken one more interface. If you already know the Java, this is the different meaning in the Java. Right? Instead of runnable, I am going to take a just example. Don't consider this as a real-time scenario. Right? It's a simple example. Yeah, by default, whenever you have interface, if you declare or if you don't declare, that is by default. It's not compulsory to have abstract, but it is easy to identify. If you write or if you don't write, that is what? Okay. Right? So if you write or if you don't write, So here if you see this movable, I did not write any abstract to this move method. But here I am writing abstract here. Right? If you write or if you don't write, by default they are what? Public abstract. See here, I'm going to compile movable here. Movable.java. It generates me a movable.class file. It generates me a movable.class file. So what I have written here, only public void move. Where it is coming from? What about this? Is it there? No, right? So your compiler adds it. If you write it, no problem. If you don't write it also, compiler adds it. The thing you need to understand is what? That is the meaning of this. By default, the methods of interface are public abstract. By default, the methods of interface are what? Public abstract methods. If you write or if you don't write. It's not execution, guys. This is I'm using lots of times. It is what? Java P stands for profiler. Profiler means what? It shows you what is your .class file contained. When you compile your source code, you will get a .class file. If you want to see what is the .class file is having, it is shows you. It's not a running app. I did not execute it. Just I'm seeing what my .class file is containing after generating. Okay, it's not executing. You cannot execute it. Java profiler we call it as. Right. So what is this here? Now what is this here? Bike. Oh, is it implements walkable? No, right? Bike is only movable. If you want to see walkable also, we will see that. What is there? That can be used for anyone. I'm using this command every day almost. And today you are asking what is the meaning of Java P? This is what? The .class file of walkable. Contains one method called as run. Okay, we'll change it to walk. And recompile it. Regenerate the .class file and check the .class file. If you write or if you don't write, they are by default. Now what this class has to do? What I have written? Public class bike implements movable. All rules whatever we have seen with the right abstract classes are applicable here. The class which implements an interface, it should override all the methods of what? The interface. It should override all the methods of the interface. If it is not overriding the methods of interface, then the class should be declared as what? Abstract class. Something that's your choice what you want to write. Is moving, running, whatever you want to write. Right? Don't see this system.out.println. Don't think this is a programming. It's not a printing, just a printing statement. Right? So a class which implements, see this, it is not extends. A class which implements an interface, it should override all the methods from that interface. If it is not overriding at least one method, then the class should be declared as what? Abstract. And you know when a class is declared as abstract, you cannot create the object. So same thing. Rules are same for abstract class and interfaces. Apart from abstract class can contain implementations, whereas interface contains no implementations. Right? Now bike. What is this bike here? I'm going to compile this. Bike.java, it's fine. It will not execute. There is no main method. There is no meaning of executing it. Java P bike. Right? It has constructor. As we know, if you don't write a constructor, one constructor will be written by the compiler and it has its own move method which I have written. Now let me take one more class here. What is that class I'm going to take here? Is public class person. Now what person objects can do? Person implements Okay, you can move as well as you can what? Walk. Now what is the meaning of person here? He has both behaviors. So it should override both methods. One is from a movable. If it is not overriding, at least if it is not overriding the method from what? At least one method. So right, this person should override how many methods? Two methods. Now I am compiling my person class here. Saying what? Boss, you cannot create a person class because you are not overriding a method, walk method from what? Walkable. If you don't override it, make your classes abstract. There are two options, same rule. Either override the methods or make these classes abstract. Right? If you make this class abstract, there is no meaning because you cannot create the object. That's your requirement dependent again. Whether you want to implement all, whether you don't want to implement all. If you don't want to implement all, then the class becomes what? Abstract. Now I am implementing all methods from what? An interface. Now let me see what is going to happen here. It's fine. It is compiled fine. It is compiled fine. Now again this syntax. If you see the syntax, one more important interview point of view question it is. As we discussed, when we discussed inheritance, I have described there are 5 types of inheritances are possible. Right? So there are 5 types of inheritances are possible. That is what I have given. And one type of inheritance is not possible through classes. That is also I have given. That is what? Multiple inheritance. Multiple inheritance is not possible through classes. That means what? A class can directly extend max one class. At most one class. It cannot extend more than one class directly. But it is possible now. That means what? So interfaces, through interfaces you can achieve one more concept, what? Multiple inheritance. Right? That means a class can implement a number of interfaces. Absolutely it can implement a number of interfaces. There is no rule. Comma separated interfaces. But when a class is implementing multiple interfaces, this class should override all the methods from what? Each and every interface. All the methods from what? Each and every interface. Otherwise you cannot create the class. Right? Okay. Right? So at the same time a class can extend as well as implement. A class can extend as well as implement. Now I am taking bike here. Bike extends vehicle. Extending means what? Getting. Person extends bike. You can write it, but is it meaningful? Person extends bike. What person gets from a bike? Right here. Public class bike extends vehicle implements what? Movable. What is the meaning of it? So bike is going to take some properties as it is from vehicle class, and it is also having, apart from vehicle class, it is also movable object. Both. A class can extend as well as implement, and it can implement what? A number of interfaces. Movable, comma, runnable. This is also one interface I have written. Right? So it can extend and it can implement, but a class can extend only one class, but a class can implement multiple interfaces. Now when a class does both, extend should be first, then implement should be next. When a class does both, extends and implements, extend should be first and implement should be next. Now is it the same? This is also same for person. Is this person class is extending any other class? Definitely person class is extending one class. If you don't write, every class in the Java extends what? A class called as what? Object class. This is what also I have said. Right? So person is not directly extending any class, but it is indirectly extending one class. That is a object class. If you don't write it, it is extending from object class. Right? So a class can extend as well as it can implement. And through interfaces, we can achieve multiple inheritance. This is one more important interview point of question. Right? So the same object can have what? Multiple different behaviors. Right? Now apart from this, you cannot write in the abstract classes as we discussed. An abstract class can contain Not only abstract methods and implemented methods, it can also contain constructors. It can also contain what? Main methods kind of things. But interface cannot contain anything. It contains purely all abstract methods. You cannot have any constructor. You cannot write any what? Main methods and all. It's not possible. It contains abstract methods only. Not possible to write anything apart from abstract methods inside an interface. Right? Okay. So did you understand where I need to take interface, where I need to take abstract class, where we go for classes? And there are three different type of structures we have discussed till date. The three different type of structures are like this. What are the three different type of structures we can create in Java? One we say as a concrete class, and the second one we say as abstract class, and one we say as interface. Nothing but fully abstract or fully abstract. It's your requirement dependent, guys, whether you want to take a class or whether you want to design it as an interface, whether you want to design it as a abstract class. That's completely up to you. There are three different types of classes you can create, with full implementation, with partial implementation, with no implementation. That's up to you in what you want to take, whether you want to take fully implementation, partial implementation, or fully unimplementation. That's up to you. That completely depends on your requirement. Whether you want to make this remote controller as abstract class, whether you want to make it as a class, whether you want to make it as a interface, that's up to you, and that is completely your requirement dependent. Getting me? Right? And the most important interview point of all of out of all these things is you can create the objects for what? There are three different type of classes you can write. There are three different type of classes you can write, but the objects can be created for which type of classes? Which type of class I can create the object here? Right? So you can write three different type of classes, but the objects can be created for only one structure, that is no. Who said which contains main method? That is wrong. The objects can be created for only concrete classes. Concrete classes means what? Implementations. Who said? Somebody said like class which contains main. Can't I create the object for person class? Can't I create the object for person class? Is it required a main method to create the object for person class? Huh? No, right? It's not required to have a main method inside a person class. Don't say that answer. Wrong. Now if I want to create an object for person class, class should be exist with all implementations. Where is the concept of main method inside this? Public class, interface, main, just main class here. I am taking main classes because of what? Too easy understand. Public, static, void main, right? So can't I create an object for person? Not possible. Person p is equals to what? New. Person, not possible. Though person is not having a main method, absolutely I can create it. Where is the main method concept inside creation of object? No way. Right? So object can be created for only fully implemented classes, concrete classes. There is no class for no class you can create the object for abstract classes, for interfaces. Right? Now p dot, what I can do here, you can call p dot move, you can call p dot walk. Though it is not going to execute anything because nothing I have written inside move and walk methods. Now let me compile my interface main class. It's fine, right? Object is created and it is getting executed. If you want to see the output, just write add one statement inside this person moves. Let me compile my program again. Person move. No, main method is not required. Who said? Wrong. Right? But here, so what is the meaning of this? Objects can be created for only concrete classes. But now I'm going to write one statement here. Carefully observe this and give me the answer in my program. Now, is this statement is correct? What is the object mean here? It is a super class. It is a class only, predefined class. Is this statement is correct? Okay. Superclass reference child class object. No. Why it is wrong? Superclass reference child class object. Obviously correct. This is also correct. There is no doubt. This is superclass reference child class object. Why it is wrong? Cannot find symbol. This is correct. This is wrong. Why these are wrong? Because move method is not there inside object class. That statement is correct. That is correct. Right? So what you can do with this abstract classes and interfaces? Though you cannot create the objects for abstract classes and interfaces, you can create what? Reference variables. You can create what? Reference variables. Right? Interfaces also can be created what? Reference variables. You can create the reference variables for interfaces. So abstract classes can have what? Reference variables, and interfaces also can have what? Reference variables. But it cannot have, they cannot have what? Objects. You cannot instantiate them. You cannot instantiate them, right? Getting me? So you can have reference variables for all. So that means what I can say? Person is a movable. That means what I can do? Though it will not compile, I can write it. Though it is not compiled here, I can write it movable. Because person is a movable object. So I can create a reference variable for what? Interface. Right? So superclass reference, child class object. Again the same story. It is not compiled anyway. Is it compiles? Yes, it compiles. It compiles because I commented these methods. If I remove these comments, then it will not work. Right? So superclass reference variable, child class object. This is fine. Now it works here. P dot move. Through the superclass reference variable, you can call child class object. You can refer to the child class object. Through that object, you can call the methods. Right? So what is movable here? Movable is a person. Movable is an interface, and person implements this movable. So you can have what? Reference variable, but object should be person, right? So whether whatever your class is, right? If it is a concrete class, you can directly create the objects and you can call the methods. If it is abstract class, what should you do here? If it is a concrete class, you can directly create the objects and you can use them. You can call the methods. But if it is abstract class, what should you do here? You cannot create the object for this. So what you should do here? You need to have a child class. Definitely abstract classes, and the methods of abstract classes need to be accessed through what? Child classes. The same thing is applicable for what? Interface also. If you have interface, you cannot create the object. So what? How to access these things? By using a child classes. So abstract class interfaces should be what? Accessed through what? Child class objects. Though interface does not contain anything, so objects can be created for only concrete classes. Remember, very important point. But reference variables can be created for all these three different structures. Right? Okay? Is it okay? What I'm saying? Do you understand? So these are the three different types of classes you have in Java. Three different type of classes. So don't think anything here. Simple. Everything, if you see everything as class, it is easy. Fully implementation, partial implementation, fully unimplementation. That is only the thing you have here. Okay, right? So let us now we will use some simple diagram here to put all whatever we discussed into one simple diagram. Right? Whatever we discussed, that means what? The relation between these three different structures. We'll try to understand by putting into one simple diagram, right? The relation between these three structures, so that this simple diagram helps you to remember all these things. Concrete class, CC means abstract class interface. Concrete class, you will understand. Let me write first, complete it, then you will understand. This is one I have. Concrete class, abstract class, again interface. Just I am trying to find the combinations here. There will be 9 combinations you come across in between these three. This is abstract class, abstract class, abstract class. Again the same story here. CC, AC and interface. I stands for interface. Right? Interface, interface and interface. What is the meaning of this here? Nothing is there. Let me complete it first so that you can understand clearly. Abstract class, abstract class, abstract class, concrete class, abstract class, interface. 1 2 3 4. One more is missing. Where is that? One more is gone. Somewhere something is missing. What is that? Here on top of this you will get it, right? Now you will understand what is the meaning of this diagram. Simple diagram. Now, so you can have a relation between these three different structures, right? So what is the relation here? Class to class, concrete class to concrete class, concrete class to abstract class, concrete class to interface. Abstract class to concrete class, abstract class to abstract class, abstract class to interface. Interface to concrete class, interface to abstract class, interface to interface. Combinations, that's it. There will be, we will have some different combinations. Now, my question is, what keyword we use, and how many classes I can implement in between this. Now first we try to identify class to class. What is the keyword we use and how many classes we implement, extend. What is the keyword we use here to create a relation between two concrete classes? Speak out fast. Extends, yes. And how many classes? Only one. One, not more than one, right? Extends keyword we use, and a class can extend only one class. What about this? This relation? Same. E comma, only one. What about this? This relation? Concrete class to an interface. Implements how many? Speak out, guys. A concrete class can implement how many interfaces? Absolutely n. What about this? Abstract class to class. So a child class is abstract class and super class is a what? Concrete class. Is it possible or not possible? If possible, What keyword and how many classes? Not possible. Possible. Say something. What is superclass? Concrete. And what is the child class? Abstract class, right? You can have a concrete superclass and you can have a abstract child class. Absolutely valid. Example, you can take object class is a superclass, right? And which is a concrete class. The superclass for all the class is a implemented class, fully implemented class. And whatever the abstract classes you create, they are all becomes a child class for what? Concrete class. You can have. Super implementation and subclass is unimplemented. Now what about this? Abstract to abstract. Keyword and number. Abstract class to abstract class. What is that keyword we use to relate these two classes? Extends comma 1. Extends comma 1. Abstract class to interface. Abstract class to interface. Speak out fast. Absolutely implements number multiple. Correct. 1 comma n. Now this is fine. This is what about this? Interface is a child and concrete class is the super. What about this relation? Interface is the child and the concrete class. Implementation class is top and the bottom is what? Interface. Tell me. Somebody says 1 and extends. Right? Now if you logically think also, not possible. How come? What is the meaning of creating a child interface for a class? What you do with that child interface? No meaning, right? So you are making out a unimplemented structure from what? Complete implemented structure. What is the meaning of it? You can make something out from unimplementation. From unimplementation you can make it implemented. But what is you are trying to do here? It's not possible. An interface cannot be extended or a interface cannot be extended or implement what? A class. No. It's not possible. Always interfaces will be what? Super. They cannot be child classes for what? Classes and abstract classes. Now is it this one? Interface. Possible? Interface to interface. An implementation and one more unimplementation. Yes, it is possible. And nothing. In the super nothing is there. In the child nothing is there. It is possible, right? Now what is the relation you will have here? Right? So because from one interface other interface is getting something. It is not implements. Implements means what? It is going to implement it. What is this interface implements? Nothing it implements. Interfaces means what? Nothing implementation. So right, the keyword is used extends only and n number, not one. This is where you come across what? Multiple inheritance with extends. Interface can extend one more interface and it can extend n number of interfaces, not one. You test it, right? So this is what you have, relation between these three different structures, keywords and numbers. And the important thing is you can simply remember it. When you have the same category of classes, nothing but abstract class and concrete class, we use extends. Same category, interface to interface, extends. When you have different things, we go for implements. Interface to class, interface to abstract class, that is where you come across implements. Simple to remember. Simple rule, but not exact. Class to abstract class, extends, interface. Whenever you see interface, it is implements. But interface to interface extends, remember this. Right? So this is what you have here. Now, as I said here, okay, now I have a super interface I have a super interface called as A, and one more interface B, and one more class C. What is this? The first one is interface, second one is what? Interface, third one is what? Class. Now can you see? Can you say what is the keywords I should use and what type of code each and every this ABC must have? Interface A, fine, exactly, with some unimplementations, but it contains interface A. If it is interface A, I only told it interface A, what it contains, this interface contains. All abstract methods, everything is abstract, right? Let's suppose there are 5 abstract methods here. How many? 5. Now this is a child interface for A. So what keyword and what is this interface looks like? B is again interface and it is a child interface for A. So what keyword? Extends, absolutely correct. And what B contains? What B contains here? What B contains? All abstract methods, because it is also an interface. Let me assume that here also have 5 methods and all are by default abstract methods because it is also an interface. What about this here? Now if I imagine this as a class, now what this should do? Implements what? Implements what here? A and B? No. Only B is enough, right? It is fine to implement both, but in this scenario B is enough. Why? Because if it is implementing B, indirectly it is also implementing what? A or not, right? So it can do both, it can do. There is no problem with that, but in this scenario, in this example, it is not required. So here you have a extends, fine. Here you have a implements, fine. Yeah, because B extends A, so it no need to extend what? A. But that is not wrong also. Now what this C has to do? Can you tell what this C has to do here? Okay, what this C has to do? If it is implementing B, what this C has to do? It has to extend. Extension, where is the extending here? It is implementing. Extension to A, B, it is not extension to B. Implements for all the methods of A and B. That means it should implement 10 methods, 10 abstract methods. Implementing means what? Overriding. It should override all 10 abstract methods from A and B interfaces. If it is not overriding at least one abstract method also, then what should happen? What will happen? It should override all 10 abstract methods. If it is not overriding, at least one method, so what this should be? There are I overridden 9 methods, but I did not override one method. So what it should be? Abstract class, absolutely correct. Right? That means what? It guarantees that there should be one child class, so there should be one implementation. Then only you can access the things. Whether you have a abstract class, whether you have interface, the methods of these things should be accessed by creating a concrete class. Then only there is a meaning. Otherwise, it is not possible, right? Can a name of 2 methods in 2 interfaces, that is A and B, can be same? Yes, you can have same name. No problem. Why no problem here? Because nothing will be there in A, nothing will be there in B. His question is, let's suppose he is asking me, so there are 5 here, there are 5 here, but here my method is like this, signature is like this, void method. My method signature is like this inside this, the same kind of method I am having inside this also. What is it? Void method. First of all, is it possible? In the classes level it is possible. We say this as what? Overriding. Same method in the super and subclasses. We call it as what? Overriding. Now, if it is the scenario there is a there is one method with same definition in both the interfaces. Now how many methods it should be implemented? How many methods should be implemented in this layer in the C class? 10. How many methods this C class should implement here? 5. Why 5 only? It's not 5 methods here, only one method. So there are 4 different methods you have. Let's suppose like this: void method 1. Don't think void method 1 when I write it. You need to imagine their abstract because it is an interface. Here method 1 is method 1, method 2, method 3, method 4. Like this I have 3 different methods: 2, 3, 4. How many I have now? 1, 2, 5. Now here I have method 5 and 6, 7, 8. Right, here 5 methods: 1, 2, 3, 4, 5. But there is one common method with the same definition. What is it? There is one common method with the same definition. Now what C class has to do? Did you get what I'm saying? Yes. Now what C class has to do? So there is one common method with the same definition in both interfaces. What is that? Void method 1, void method. And 8 methods are unique. 8 methods are unique. Only one method is common. Now how many methods you should override? 10, 8, 9. How many? 9. It's enough to override 9. That means what? No need to have 2 different implementations for this one and this one. Only one implementation is enough. Only one implementation is enough. So what happens? So here 4 unique and one common. So totally 9, not 10, right? So that is where. So these are all some tricky bits anyway. But if you do experiments, then you will come across all these things. Just need to explore your subject. Whatever I'm discussing, you need to add something and you need to experiment. That is how you learn the subject. Don't stick whatever I'm teaching. It is not entire subject I'm teaching. Not possible for any faculty. That is also I'm accepting. Right? Not possible for any faculty to discuss entire subject with each and every point. You need to explore this. You need to experiment it and you need to practice it. Then you will come out with new points. Okay guys.